Now, generally speaking, the offset is going to take a surface. Now, that could be part of a quilt, could be part of your solid geometry. It's going to take a surface or a solid face and make a new surface, offsetting away from the existing one. Now, besides doing that standard offset, we're going to see there's lots of other options inside of that particular feature. But before we get into the offset, I want to show you a selection technique. Now, if you've seen this and you've used it, this will be a review. But if you haven't seen this, it's a very handy little tool anytime you need to pick a bunch of adjacent surfaces. And really for any reason. Maybe you're picking those surfaces because you want to copy them or thicken them or offset them, exclude them out of a shell, maybe just change the color of them. If you're looking to pick a bunch of adjacent connected surfaces, one way to do that is to hold the control key and pick every one of them. Of course, that's going to be the slow way. If there's hundreds of them, you'll probably miss one by mistake or pick one that you didn't mean to. There's a selection technique in Creo called the seed and boundary. It's almost a secret because there's no menu pick for it. Creo never really mentions that you can do this seed and boundary. You just need to know what the technique is, and that'll save you a lot of effort anytime you need to pick a bunch of adjacent connected surfaces. To do this seed and boundary, you're going to start by picking one of the surfaces you're trying to select. In my example, I want to pick all the inside surfaces of this container. So I start by picking any one of them. And it really doesn't matter which one I start with, maybe the sidewall there. That's going to be referred to as the seed, the surface you pick. What gets selected in this process is the seed you start with, plus every surface that touches that seed, plus every surface that touches that bigger set, up to and not including boundaries that you pick while holding the shift key. Now, in this example, all those inside faces are bounded by that one surface on the top. So I just need to pick any one of the inside faces as the seed. Then I need to hold the shift key. So not the usual control key, but the shift key this time. And as I'm holding the shift key, pick as many boundaries as you need to. That boundary is going to stop the seed from growing into the adjacent surfaces. It's going to stop at the boundary and not include the boundary as part of the selection. So with just 2 mouse clicks, I can wind up picking all those interior surfaces. You pick one as the seed, you hold the shift key, pick as many boundaries as you need to, let go of the shift key, and it picks the seed, everything that seed was touching, everything that entire set was touching, up to but not including the boundaries. Now, of course, depending on what you're trying to pick in the shape of the model, you might need more than one boundary. In this example, all those inside faces were bounded by one surface. So with just 2 mouse clicks, I was able to pick those. And again, this is not really a command I start. I don't need to tell Creo I'm doing a seed and boundary. There's no icon or menu pick for it. I simply just go to the model, click on one of the surfaces, hold the shift key, pick as many boundaries as I need to. And that can be used anytime you're picking a bunch of adjacent connected surfaces for any reason. Maybe you're going to copy them, maybe you're going to offset them, change the color of them. That seed and boundary is an efficient way to pick up. Now, to build a new surface, by taking an existing surface or an existing solid face and make a new surface as an offset, you can build this feature called an offset. And when you start the offset feature, Creo's going to default to what's called the standard offset. The standard offset's going to make one new surface by offsetting the existing one. Now, where you can run into failures here, the most common reason an offset's going to fail is because you're offsetting to the inside of a radius by more than the radius. The radius that you're offsetting to the inside of is typically the limiting factor on how far you'll be able to offset. Once you reach the radius dimension on the offset, you've gone to 0 on the radius. Any further than that, it's going to overlap on the other side and fail. So the standard offset is going to allow you to pick either one surface, one quilt, or one solid face. If you're looking to offset maybe several solid faces or several surfaces from a quilt, you're going to notice if you hold the control key and pick more than one item, you're not going to be able to do the standard offset. The standard offset is limited to picking one entire quilt, one surface out of a quilt, or one solid face. If you're looking to offset maybe 7 or 8 solid faces, you could turn those into a single quilt, or you could copy a new single quilt on top of those solid faces. So if you're looking to offset multiple things at the same time, you would have to select them either with the control key or maybe that seed and boundary selection, copy them, and then just paste a new quilt on top of it. That new quilt is one item, and you would be able to do the standard offset on that one single item. Now, when you're in the offset feature, the standard offset is going to take the shape that you're offsetting, offset it to one side or another at a linear distance. You just type in the linear offset value. When you're offsetting to the inside of a radius, that radius gets smaller by the offset distance. And again, that's typically where you're going to hit a failure when you're offsetting to the inside of a radius by more than that radius value. In this picture, I start with this green surface, and the smallest radius is up here on the top. And let's say it's about 25. So if I build a new standard offset surface, offset to the inside by 25, I would expect it to work right at 25, but that radius is going to disappear on the inside at that point when you offset by the radius value. If I were to make that offset any further, it's going to overlap on the inside, the radius goes past 0, and that's where you're going to expect the failure. Now, maybe I want to look at that green surface before I offset it and figure out what the minimum radius is. There's a tool called Radius on the analysis menu where you can pick that surface, and then Creo would find where the smallest radius is. It would locate that point for you and then tell you what the smallest radius is. Then, of course, if I'm offsetting to the inside of that radius, that number there would be the maximum distance I can do the offset. Well, unless I use one of the other options. When you get into the offset, it wants to start with a normal to surface offset, the true offset, where it offsets to the inside of a radius by the radius value. If that normal to surface doesn't work, usually because you went too far to the inside of a radius, there's a way to approximate this. If you don't need the perfect true normal to surface offset, where you have the same offset value at every point, measured normal to the surface at every point, instead of this normal to surface, there's two different ways to approximate the offset. There's a method called an automatic fit and a second one called a controlled fit. Now, these options that we're looking at here actually come up in two features. The offset feature and the thicken feature pretty much do the same thing. They have the same options in it. The offset just makes the new surface. If you're doing a thicken instead of the offset, the thicken will make the new surface and then fill in between the two of them with solid material. So whether you're doing this offset feature or the thicken feature, you have these same three options. You can do the true normal to surface offset, where you get the same thickness at every point measured normal to the surface. And with the thicken or the offset, you can also approximate it with the automatic fit or the controlled fit. So let's say I want to offset, or for that matter, thicken to the inside of that surface by 30. If I try the normal to surface, it's going to fail at the 30 because that passes the radius. But if I switch the offset or the thicken feature off of normal to surface and go to this automatic fit, it'll actually produce the new surface. Now, it's not a true offset. You don't have a distance of 30 at every point because that was impossible, geometrically speaking. This automatic fit is going to do a true offset where it works, where it fits. In the areas where it didn't, it's going to do more of a scaling command. Instead of truly offsetting the surface, letting the radius go to 0 and fail, it's going to scale down that geometry and then automatically try to position that scaled down surface so it approximates an offset. Again, geometrically speaking, the true offset was impossible. So this automatic fit has Creo automatically try to scale the surface, make it look like an offset the best it can, and give us our new surface here. So even though this outside radius was only 25, and I'm offsetting to the inside of it by 30, when I switch it from normal to surface to the automatic fit, it actually works at a value of 30. Now with the automatic, you're letting Creo automatically figure out how to scale down the surface and kind of translate it into a position, translate the scaled down surface so it looks like an offset. You might not like how it does the translation. In this example, when I go to my automatic fit with that value of 30, I'm going to notice that my offset surface is kind of translated down. If you notice, like the side edges are not horizontal with each other. I have a little taper on the side edges. If I was thickening that, the solid geometry would have those red edges. If you don't like what the automatic fit does, if you don't like how Creo automatically positions that scaled down surface, then there's a third option called the controlled fit. What you can do with the controlled fit is disallow translations in certain directions. In that left-hand picture, I don't like how Creo translated my offset surface downward. So I can switch off the automatic fit, go to the controlled fit, and ask it not to translate in that vertical Y direction. When I turn off the allowable translation for Y, then it won't translate the scale down surface along the vertical Y axis. And now you can see my, if I thickened it, my edges across the bottom would be horizontal. So that's really the order you want to try the offset feature or the thicken feature. Leave it on the default of normal to surface. And if it works, you get the perfect offset, the same distance, normal to the surface at every point. If that normal to surface fails, try the automatic fit. Let Creo automatically scale down the surface, try to translate it to look like an offset. If you don't like how it translated the surface in the automatic fit, then go to the controlled fit. In the controlled fit, you can turn off the translation along X, Y, or Z relative to a coordinate system you pick, and then that disallows the translation in those directions. Now, like we said, when you go to build an offset surface, you can pick one surface out of a quilt, you can pick one entire quilt, or you can pick one solid face. Let's say that this geometry on the left was one entire quilt, but I don't want to offset the whole thing. I would start by picking the entire quilt. You'd have to pick the entire quilt. Then when I go into the offset, there is an exclude option. When I get into the offset feature, I could ask Creo to exclude these three surfaces out of the quilt, and then it's going to offset the other ones. Now, if you're doing one of the approximations, like the automatic fit or the controlled fit, you have to do the entire quilt. If you're doing the true normal to surface offset, then Creo will have this exclude option where you can exclude certain surfaces out of the quilt. So all of these things that we've been talking about here are a part of the standard offset. You can do the normal to surface, you can do the automatic fit, you can do the control fit. Same thing would be true if you're doing a thicken. The thicken feature has the same options as the offset surface. Now, besides that standard offset, on that drop-down menu, there are three other choices. We're going to look at those. So one choice, besides the standard offset, is this expand. And with the expand, again, you can take a solid face, you can take a surface, you can take a quilt, and it's going to offset it or translate it. You're going to have two options here. And if you're doing this expand on a solid face, once it offsets or translates the solid face, it's going to fill in between them with solid material. So here's an example of a solid part. I want to take this right-hand face, this solid face, and I start the offset feature. So pick that face, hit the offset icon. And when I get into the offset, I can change it to this expand. Then I can either translate that surface, keeping the exact same shape, or I can offset it. In this example, we're offsetting that surface to the right. So once again, we're offsetting to the inside of a radius. So there's going to be a limit as to how far I can offset. The radius of that original surface was about 16 there. As soon as I offset at 8, I'm going to get a perfectly sharp edge here, or exactly half of a cylinder. And that's really going to be the limit as to how far I can offset. The radius is getting smaller. If the original surface, the green one, had a radius of 16, and I'm offsetting by 7, of course, the new surface there would have a radius of 9 because we're offsetting to the inside. And then since I'm expanding out a solid face here, it's going to fill in between the new surface and the original with solid material. And it actually makes the solid part bigger. If I offset in the other direction, it would actually cut away some of the solid geometry. Now, besides doing an offset like we are here, when you're in this expand, you could go under options and ask it to translate the surface instead of offsetting it. The translate is going to keep the exact same shape as the original surface. Same shape, same size, and it's just going to move the surface. When I switch over to a translate, you're going to need to pick something planar to translate normal to, or something linear to translate parallel to. Then you just tell the computer how far you want to translate it, like 7. Again, since I'm doing a translation, This new face has exactly the same shape and radius as the original face. There would be no limit as to how far I could translate that particular surface. Now, also in this expand, you don't have to expand the entire face or the entire surface. When you're doing the expand, you can draw a sketch that gets projected onto the surface, and then it's going to do the expand just inside of that sketched region. So here's an example where I started with this cylindrical shaped surface and just extruded an arc to make a surface. Now I want to expand a portion of that surface. So I pick the cylindrical shaped surface, start the offset feature, and then I'm going to put it on expand. Then when I go under options, there's an option to expand just a sketched region. So pick a plane, draw a sketch. That sketch gets projected onto the surface. It projects normal to the sketching plane. And then it does the expansion inside of the sketched region. On a plane up above that cylinder, I sketched a rectangle. That rectangle gets projected onto the cylindrical surface. And now it does the expansion just inside of the sketch instead of expanding the entire surface. Now with this expand, it's going to ask, should the side walls of the expanded geometry be normal to the surface you're expanding, or should they be normal to the sketching plane? In the top example, I have the side walls of the expanded geometry, like this wall here, normal to the surface that I'm expanding, normal to that cylindrical shaped surface. In the bottom picture, I changed it to the other option, where I asked the computer to keep the side walls normal to my sketching plane, the plane that I sketched the rectangle on. In this example, the sketching plane, and I'll try to draw it, was a horizontal plane, like I had a datum plane here. That's the plane I put the sketch on. And when I asked Creo to have the side walls normal to the datum plane, the side walls will be normal to the datum plane. So again, this is an option within the offset feature called an expand. In this example, we're expanding within a sketched region. Then also on your offset feature, besides the expand and the standard offset, there's a third one called with draft. It's really an expand with draft, where it's going to do the expand like the expand did, but then it's going to draft the expanded surfaces. It's going to add a draft angle to that. So again, in this option, we started an offset. We're using the option called with draft. Think of that as an expand with draft. We're expanding inside of a sketch. I drew this rectangle sketch on a plane below the cylinder. Creo projects the sketch onto the surface and does the expansion within that surface. Now, just like the regular expand, when you do the with draft, it's going to ask, should the sidewalls be normal to the surface you're expanding, or should the sidewalls be normal to the sketching plane? And then it's also going to ask, should the sidewalls be straight or tangent? In all the examples I've shown you so far, we had straight sidewalls. If you switch that over to tangent, then it's going to make the sidewalls of the expand tangent to the offset surface and tangent to the original surface. So it's going to bend or curve those surfaces. So they're tangent to the new offset position and tangent to the original surface as well. Now, since I'm using the with draft, in the bottom picture, I asked for the sidewalls to be straight, and I asked for them to be normal to my sketching plane, which was this plane down here. But notice the sidewalls are not normal to the sketching plane. They're tilted in, and that's because I'm doing the with draft, and I set the draft angle to be 10 degrees. So it started with the sidewalls normal to the sketching plane, and then it tapered them in 10 degrees. Now, certainly you could do that shape without the draft. You could do the regular expand, and then you could come back and add a draft feature afterwards and get that shape. But if you know you want the surfaces tapered right away, you might as well do the with draft, where it puts the draft on right for you. Then for the sidewalls, you can make them straight like the left-hand picture or tangent like the right-hand picture. And what they're tangent to is the offset surface and the original one. All the adjacent surfaces will be tangent with each other. Now, besides the standard offset, the expand, and the with draft, there's a fourth choice on that menu called the surface replacement. The surface replacement is going to let you select a solid face from the model and replace that solid face with the surface or with the quilt, making the solid take on the shape and the position of the quilt or the surface that you replace with. So in this example, the gray geometry is all solid. The bluer geometry is the surface. It's one single quilt. And now I'm going to do a replacement. I'm going to start by picking the solid face that I want to replace the shape and position with. I'll pick the top of the cylinder, start an offset feature. And now when I get into the offset, instead of a standard offset, which would be the default, I'm going to switch it to a surface replacement. Then Creo is going to ask which surface or which quilt do you want to replace it with. In that top example, since my quilt is down below the solid face that I'm replacing, it winds up cutting away all the solid above the quilt. You could actually get the same shape with the solidify as a cut, but here we're doing a surface replacement, which is a command within the offset feature. Now in the middle picture, I'm still replacing the top face of the cylinder, but this time I moved my surface quilt up higher. So now it needs to add a bunch of material to make that solid face take on the shape and the position of the quilt that you're replacing with. And then this replacement can be kind of a unique feature in Creo in that it can actually add and remove material at the same time. In the bottom picture, part of my quilt is above the solid face that I'm replacing on the back side of the part, and part of the quilt is buried down in the solid. So when I replace the top of the cylinder with that surface quilt, it needs to add geometry on the back side of the part, in that area back there, and then it needs to remove some geometry on the front side. It's going to do whatever it needs to do to make the solid face that you're replacing take on the shape and the position of that surface quilt. So again, we have 4 options within the offset. You have the standard offset. There's one called expand, another one called with draft. It's really an expand with draft. And then that 4th option was the surface replacement. So to see all those, I have several examples for you. In 1 second while I drink my water. So let's start by taking a look at how that seed and boundary works. Anytime you need to pick a bunch of adjacent connected surfaces for any reason at all, you can use the seed and boundary. Again, it's not a menu pick. You don't need to select an icon. You don't need to tell Creo you're doing a seed and boundary. Just start by picking one of the surfaces you're trying to select. Here, I'd like to pick all the inside surfaces of this container. So pick any one of them. It doesn't really matter which one you pick here. And I'm going to start with that surface. Then to have Creo pick every surface that touches that one as well, every surface that touches that bigger set, up to but not including the boundary, I need to hold the shift key now and pick my boundaries. So with the shift key, not the typical control key, with the shift key, I'm going to pick this top surface. And then as soon as I let go of the shift key, Creo picks the seed, everything that was connected to the seed, everything that was connected to that, up to but not including the boundary. So with just 2 mouse clicks, I was able to pick all those inside surfaces. Again, if I start over, maybe I pick this surface as the seed, hold the shift key, pick that surface as my boundary, let go of the shift key, all those inside surfaces get selected. Now, depending on what you're trying to pick and the shape of the model, you might need more than one boundary. With the cut in the back wall, if I want to pick just the inside surfaces, I would now need 4 boundaries. This top surface and all 3 sides of the cut to stop the seed from growing and connecting to the outside of the part. I would need 4 boundaries. So let's pick maybe this surface as the seed. And then with the shift key, I'll pick my 4 boundaries. I think I'll start with the hidden surface. I'm holding the shift key, put my cursor here. Now, that's not the surface I want. I want the one behind it. So I can right click. There's my first boundary, picked it with the left button. Still with the shift key, this is going to be my second boundary. This will be my third boundary, still holding the shift key. This will be my 4th boundary. Then when I let go of the shift key, it winds up picking all those surfaces. Now, maybe I miss the boundary. Maybe I don't notice that hidden surface. Let me start over by picking off the part here. I'll select a seed. Maybe I only pick the 3 visible boundaries. With the shift key, I'll grab 1 boundary here, 2nd boundary on that surface, and a 3rd one up here. Missing that hidden surface, that allowed the seed to connect across the missing boundary and get the outside of the part. So it wound up selecting all those outside surfaces. If you miss a boundary, you don't actually have to start over. You can just go back to the shift key. Noticing it selected way more than what I wanted because I missed a boundary. I just go back to the keyboard, hold the shift key again. I'm now holding the shift key again. And I can add in the fourth boundary that I needed, let go of the shift key, and it wound up picking all those inside surfaces. Again, anytime you're picking a bunch of adjacent connected surfaces for any reason at all, here I just wanted to color them, you can use that seed and boundary selection technique. Now, as far as doing an offset surface, we're going to notice we're limited to picking one item, either one surface, one entire quilt, or one solid face. If I were to pick this solid face, one item, I would be able to go to the model tab and do this offset feature. The standard offset is going to make a new surface by offsetting the one that I selected. And of course, when I'm offsetting to the outside like this, there's really no limit as to how far I can go. But notice what happens if I try to pick two solid faces. If I go to the model, pick this surface, and with the control key, a second one. Now when I start my offset feature, put it on the standard offset, it only offsets the second one you picked, or the last one you picked. The offset is limited to picking one solid face, one surface of a quilt, or one entire quilt. So if I really wanted to offset those two faces with a single offset, I would need to make a quilt on top of those. So what I would need to do in that case is pick this solid face, hold the control key, pick the other one, right click and copy those two solid faces, then right click again and paste a new surface quilt on top of it. There's a new surface, or a quilt as we call it. And then I could offset the entire quilt. But notice when I come over the quilt, it highlights just one piece of it. Now I could pick the one piece and offset it. I want to offset the entire quilt. To get the entire quilt selected, I can just right click and now it picks the entire quilt. Or I could put my selection filter on quilt and pick the entire quilt easily. Then I can go to the offset and it takes that entire quilt and offsets it to the outside. So if you want to offset a portion of a quilt or a bunch of solid faces, you would first have to copy those, paste a brand new surface quilt on top of them. Then you could do the offset on that entire surface quilt. Now let's look at the main limitation of doing an offset. And that's offsetting to the inside of a radius by more than the radius. So here's a part with a complex curved surface. I want to offset to the inside or below it. And before I do that, I'm interested in knowing how far could I get the offset to go? It's really going to be the minimum radius, and Creo can find that for you. It can locate where that minimum radius is and even tell you what the value is. On your analysis tab, under inspect geometry, you have this radius tool. That's where you can pick a surface or a solid face, and it'll find the smallest radius for you. And it tells me here that smallest radius is right at this point, and it's about 106.7. So if I offset to the inside by 106.7 or less, I expect it to work. If I go more than 106.7, I would expect a failure. This radius tool finds the location of the smallest radius and tells you what the number is. Now to offset this one quilt, I can pick the quilt. In the mini toolbar, I could start an offset feature. And as I drag that offset to the inside, I expect it to work until we hit 106.7. So as I drag it, to 105, I see the preview, it's working. If I drag it any further than that, like to 108, it fails. If I put that at exactly 106.6, it works. If I take the offset, put it at 106.8, we're going to get the failure. So we've already determined where it's going to fail by finding that minimum radius. Now, maybe you want a little bit more help. You want the computer to really visualize where the problem is. There's another tool, another analysis tool called an offset analysis, where it's going to offset the surface, show you this grid or this mesh surface. And even if that self-intersects, it's going to be able to produce it. So I can do an offset analysis. I can offset to the inside of that radius by more than 106.7, and I'll be able to visualize where that surface self-intersects. So if you're having trouble figuring out what part of the surface is causing the failure, doing this offset analysis is very useful. Also, if you're trying to do a shell, the shell is going to fail for the same reason as an offset, because you're going to the inside of a radius by more than the radius. But the shell doesn't really have any tools at all to help you figure out what's wrong with it. Nor does the shell have those approximation options like the offset surface does. So if I'm wondering why does 107 fail, well, then maybe I should go and do this offset analysis. That's going to show you the surface, the offset surface, even if it self-intersects. When I go to this offset analysis, I can pick this surface to be offset. And even if I go all the way to 135, where the preview of my surface was failing because it self-intersected, this offset analysis with the mesh surface is able to produce it. And then if I can zoom in, I can see right in here, all of that geometry loops back through itself. It self-intersects, and that's where the problem was. If I take that to less than 106.7, like 103, then I can see the surface does not self-intersect. It looks good there. If I bump it up to something bigger than 106.7, you can see we're getting a self-intersect. So if you're offsetting a surface or thickening something or shelling it and you're getting a failure, running this offset analysis can really help you spot what part of the surface has the problem. And we can see in this area right here where the smallest radius is, that's where we were getting that failure. So all of those are examples of that standard offset producing a new surface. Now let's look at one where my standard offset doesn't work the way I want it to. Let's look at this part. So here I've created a surface quilt and I want to thicken it. The thicken feature and the standard offset have the same options. You can do the true normal to surface. You can approximate it with the auto fit. You can also approximate it with the controlled fit. So I want to take this entire surface quilt. Let's put our selection filter on quilt, pick the quilt. And whether I'm doing an offset or a thicken, I'm going to see exactly the same options. I actually want to fill in between the two surfaces with solid material. So I'm going to do a thicken in this example. I want to thicken to the inside, the other side. I'll click on the arrow to flip the direction. And I want a wall thickness of 0.04. So it does the offset, fills in between the surfaces with the 0.04 thickness. And now I have a solid part that looks like this. When I spin it around and look at the inside, you can see this radius is almost gone to zero. There's just a little bit of that radius left. So the outside radius was something bigger than 0.04. I think it was around a 0.06. But now I've changed my mind, and I really want the wall thickness at a 0.8, which is bigger than the smallest radius on the outside. If I go back into that thicken feature with that at definition, change the thickness dimension to a 0.8, and hit the check mark to finish the thicken, it says it cannot be created as defined. And do you want the computer to automatically fix it for you? Well, that sounds like a good idea. So we can say, yes, let Creo fix this and make it work. And now I do get solid geometry. It was able to thicken at least some of the model at that 0.8 thickness. Although this is not what I wanted. All the surfaces that didn't fit, all the surfaces that had a radius less than that 0.8 were not thickened. They were left out. Now, with my surfaces displayed on top of my solid geometry, it's a little bit difficult to tell that there's a bunch of holes in my solid geometry. So let's take all of our surface quilts here. Let's hide those out of the part. And now you can see my solid geometry has a bunch of holes in it. When that message came up asking if you wanted Creo to automatically fix the thicken, what it did is it just excluded out of the thicken all the surfaces that didn't fit. And that's why we wound up with a bunch of holes. So the fact that it made the feature is not really any good to me because I really wanted to thicken all the surfaces. I didn't want to exclude the ones that didn't work. So we're going to look at the approximations. We know the true normal to surface doesn't fit in this model. So now I'm going to come back and approximate it either with the automatic fit or the controlled fit. And in both of those examples, it will be able to produce solid geometry for it. Let's go back into the thicken. And the first thing I want to do is not exclude the surfaces that didn't work. We're going to go under options and we're going to remove all the excluded surfaces. Of course, it'll fail if we don't remove them unless we do the approximation. Instead of the true normal to surface, I'm going to change it to the automatic fit. Again, this is where Creo does the offset where it fits, and where it didn't, it does more of a scaling operation. And then it takes that scaled down surface and tries to translate it into a position so it looks like an offset the best it can. And at that 0.8 thickness, even though this radius in here was a 0.6, it is able to produce the geometry, but I don't like what it did to the bottom face. So I wanted this bottom face basically, horizontal. Let's go to a front view. And we can see that bottom face is tapered about 40 degrees. I really just wanted that to be a horizontal surface in this view. So I don't like how it took that scaled down surface and translated it downward, making that bottom face tapered at that 30-degree angle. So although the automatic fit worked, it's not giving me the shape I wanted. So I'm going to go back to the controlled fit and turn off the translation in that vertical direction. And then I think I'll finally get a shape that I like. Let's go back into the thicken. Under options here, we're going to switch it to the controlled fit, which allows you to ask the computer not to translate along X, Y, or Z. Now in this model, the vertical direction here is the Y-axis. So I'm going to turn off translation along the vertical Y-axis. And now when it does the scaling and the translation, the bottom surface remains, normal to the sides. Or if we go to a front view, and that bottom surface is perfectly flat. So that's really the order in which you want to try a thicken feature like we're doing here, or the offset feature. Try the true normal to surface. If that works, you have the perfect offset. If it fails, look at the automatic fit. If that doesn't give you the shape you wanted, you can switch over to the controlled fit and ask it not to translate in the X, the Y, or the Z direction. That same option is in the thicken as it is in the offset feature. Now here's a solid part where I'd like to take this right-hand face and expand it. I want to offset it to the right, fill in with solid material. So I'm going to pick that one solid face. In the mini toolbar here, we'll start the offset, and it defaults to a standard offset. It's just going to make a new surface by offsetting that face. Instead of the standard offset, this is where I want to do the expand. I'm going to go to the offset type menu up here in the tab for the offset, switch it to an expand, and now you can see as it offsets the surface, it's filling in between them with solid material. Now there's a limit as to how far I can go. Let me show you how big the part is here. If we were to go in and measure the diameter of this surface in the radius, we can see the radius of that surface is at a 16. So as I offset to the inside, of course, the radius keeps getting smaller. When that hits half of a cylinder, where you get a perfectly sharp knife edge on the end, that's going to be the limit. I won't be able to offset more than 8 without getting a failure. So let's grab that solid face. We'll start an offset, switch the offset into an expand, and now I can expand that up to 8. You see the new surface keeps getting a tighter radius here. And as soon as I cross over 8, we get a failure. Right at 8, you have a perfectly sharp edge there, like the cylinder's tangent to the back wall. And if I go less than 8, of course, it's going to fit. Now, with this expand, you don't necessarily have to offset the surface. You can do a translation instead. And of course, if we're translating, there's not going to be a limit as to how far we can translate. When we go under options, I can take this expand, switch it from a normal to surface into a translate instead. Now, when you translate, it's going to move the surface. You need to pick something planar to translate normal to, or something linear to translate parallel to. Let me just pick this linear edge. And now Creo is going to take the blue surface, the one I'm offsetting, or actually translating now. It's going to translate that surface some distance and then fill in between them with solid material. And since I'm translating, I can translate that as far as I want to. It's keeping the exact same shape. Remember that original radius was at a 16 when I used the translate option. If I were to come back and measure the radius of the new surface, you can see it's 16 just like the original. Now, if I go back to that expand, if we switch it back to the normal to surface here, set that value at a 7, now I'd expect the radius of the new surface to be 9, or 16 minus 7, because we're offsetting to the inside of the radius. If we want to confirm that's true, we could go back to our diameter measurement, and we can see the radius is 9, or 16 minus 7. So that's the expand done on a solid face. where it fills in between the new surface, either the translated surface or the offset one, and the original surface with solid material. Let's look at doing an expand just on an infinitely thin surface here. Let's take a look at this one. Or I just have this cylindrical surface. I want to expand a portion of it. I want to draw a sketch, project the sketch onto that surface, and do the expansion just inside of that sketch. So we're going to start by picking this surface. I'll start the offset feature, and it starts with just a standard offset. Let's switch that over to the expand. And now instead of expanding the entire surface, I can do the expansion within a sketched region. I'm going to define a sketch, let's say on this datum plane. Go into Sketcher here. I'm going to sketch just a rectangle somewhere, about like this maybe. Creo is going to take that rectangle, project it up onto the surface that you're expanding, and then it does the expansion just within the rectangle, or just within that projected sketch. If we go to a front view here, you can see the side walls of the expanded geometry are vertical or normal to my sketching plane. If you'd rather have the side walls of the expanded geometry normal to the surface you're expanding, well, just switch it over to surface. Now the side walls are normal to the surface. If you want it to go the other way, you could use a negative dimension or just hit the flip icon and it'll offset on the other side. Of course, going downward, there's a limit as to how far I can go in that direction. So there's your offset. So it's actually, this one's called an expand, doing the expand within a sketched region. Then we have the one called with draft. It's really an expand with draft that takes the expanded geometry and adds a draft angle to it. To see an example of one of those, again, I have a cylindrical surface. Let's take the surface, start an offset. I'm going to put it on with draft this time. I want to do the expansion with draft inside of a sketched region. I'll put the sketch on that plane, that being the top plane. Let's draw a centered rectangle. Go about like that. Creo is going to take the rectangle, project it up onto the sketching plane. Now, since I did the expand with draft, I now have a draft angle. Right now, I have the side walls normal to the sketching plane. So the side walls are perfectly vertical. If I want to taper them from that vertical position or be normal to the sketching plane, I have the draft angle. If I set that draft angle at 15 degrees, now the side walls are tapered in 15 degrees. Let's put that back at 0. If I switch it over and have the side surfaces normal to the surface I'm offsetting, the side walls are now normal to that surface, but I have the draft angle. So from there, if I draft it 30 degrees, now they're tapered in 30 degrees from the original position. When you do the with draft, there's an option to have the sidewalls be tangent. The sidewalls will be tangent to the original surface and the offset surface. Right now, the sidewalls are straight. If I switch that over to a tangent, now it has to bend the shape. So the sidewalls are tangent to the original surface and also tangent to the surface that you're offsetting. So that one there is called an expand. All right, then for a couple more examples here, let's take a look at doing a replacement. The replacement is also an option within the offset feature. The replacement is where you can take one solid face, and that's really the big limitation of the replacement, is that you can only pick one solid face, and then replace that solid face with a surface quilt. I want to replace the top of my solid block with that wavy surface quilt. But you'll notice the quilt is not the same size as that surface I want to replace. If we go to a front view of this part, my quilt stops right here. It doesn't reach out to the side of the block. And over on the right side, the quilt is oversized, goes past the top surface. The fact that it's oversized is irrelevant. It just ignores the excess. If the quilt you're replacing the solid face with is smaller than the solid face, Creo will automatically extend it. It's going to attempt to do a same curvature extension on this surface. It's going to extend it out at the same curvature value until the replacement quilt's big enough. So when you're replacing a solid face, you don't necessarily need to make the surface quilt that you're going to replace with exactly the same size as the solid face. If the surface quilt is oversized, Creo just ignores the excess. If it's undersized, it'll attempt to do a same curvature extension of that quilt until it's big enough. Now, since I want to replace the top face of the solid, I'm going to pick that solid face to start with, start an offset feature, and then instead of a standard offset that just makes a new surface, we're going to go to the fourth option called replace surface. Creo's going to ask, what quilt do you want to replace the solid face with? I'm going to pick this quilt, and then it does the replacement. Again, for this area where the quilt was too small, it just did a same curvature extension until it reached to the end of the solid face I'm replacing. And then it makes the solid take on the shape of the quilt. Now, in that example, it had to add and remove material at the same time. In the areas where that quilt was buried in the solid, it had to cut away material in here. Where the quilt was up above the solid, it had to add material. Again, I picked a solid face, went to the offset, put it on replace surface, and picked that quilt. That's part of the offset command. Then for just a couple more examples, let's take a look at this part. One second while I drink my water. Where I want to engrave or cut down into this top face or into that surface, this recycling logo. So I've already made a sketch, and now I'd like to do an expand with draft, the with draft, inside of that sketch. I want to take this sketch, project it onto that surface, and then do the expansion. So since I want to expand part of this surface with draft, I'm going to pick that surface. That could be a quilt, or in this case, it's a solid face. I'm going to start the offset, and now we're going to use the with draft option. And then I want to use this sketch. Now, if that sketch did not have text in it, it does have text in it, but if it didn't have text, I would be able to just pick that existing sketch and it would project it and then do the expand. But since there's text in there, when I pick the sketch, it doesn't accept it, nor does it actually give you an error message. If you have text in the sketch, you can't pick it. You have to make a new sketch. So I'm going to define a new sketch to do the expansion inside of it. I'm going to go to this plane, the text plane, and build a sketch. The reason you can't pick a sketch with text is because when you're doing these expansion operations, the text function is grayed out up here. So it was important that I made the sketch ahead of time. If I tried to make a new sketch here, I wouldn't be able to use the text function to get the letters. Therefore, I made the sketch ahead of time, just as a standalone two-dimensional sketch feature, where I was able to use the text function. Now, to trace over that existing sketch, I'm going to use the project command. Let's go to the project. I'm going to pick any one piece of that sketch. I'm going to go to the details of my projection here, make it rule-based, where I can ask Creo to use all the curves in that feature, every curve in that entire sketch. Hit the green check mark to complete the projection. Now, Creo is going to take this sketch on the text plane. It's going to project it onto this surface, and then it's going to do the expand with draft inside of the projected sketch. So I go ahead and finish the sketch here. It does the expansion. Now it's raising up the letters. I want a right view here. So those letters are getting added to the outside. I want them to go to the inside, so I just flip the direction. Now it's cutting the letters into the part. For the draft angle, let's put it at 2 degrees. Now I have 2 degrees of taper. And of course, it looks terrible because when I project it onto that slope surface, it's on almost a vertical surface, it way stretched out the letters. So I really need one more operation to make this look right. I really need to sketch squash down letters that are way narrower at the bottom. So when they get projected onto that vertical surface, they don't get stretched out. I really need to do an intermediate operation in between my expand with draft here, that being a wrap. The wrap command will take a sketch or a curve and drop it onto a surface. Unlike the project, when you do a wrap, it's more like thinking of what you're wrapping as a bunch of pieces of string with a fixed length. The wrap is going to take all those pieces of string with a fixed length from the plane they're on and just drop them onto a surface. And since that piece of string has a fixed length, when I do the wrap, as opposed to the project that I have here, it's not going to change the dimensions. Like in this example, the length of that straight line in the H was 1 inch long. Of course, the projected geometry down here is way longer than 1 inch. It's about double that. If I do a wrap to get that image dropped onto the surface, then we won't distort the shape of the letters. So let's take the offset that we've done here. Let's delete it. And before I do the offset, I need to know what that squashed down sketch needs to look like. So we're going to take the original sketch and we're going to wrap it onto this surface. Let me pick the original sketch. In the editing group here on the model tab is your wrap. And it's basically going to treat this sketch as a bunch of pieces of string with a fixed length. It's going to pull the plane out from under them and just let those pieces of string fall onto the surface. They fall normal to the sketching plane. And now I have that shape wrapped onto the solid geometry and the letters are not distorted. Now I know what the letters need to look like in the sketch for the offset. So we can pick the solid face, start an offset. We're going to use the width draft. I do need to make a new sketch here. I'll put that new sketch on this same datum plane. And I just want to trace over the wrapped letters. It's going to give us a very funny shape up on the sketching plane. The letters are going to be way squashed down at the bottom, but that is the shape to make this look correct. I'll go to the project command, pick any one piece of my wrap here. Let's go to the details for the project, make it rule-based, use all the curves in the feature, hit the green check mark. Now, if we go to our 2D view of the sketch, you can see I have these letters that are way squashed down at the bottom. So once the wrap projects them, they'll be stretched back out at the appropriate length. So I had to do this intermediate wrap to get my offset to look the way I want it to. And then if we go to our right view, there's raised letters. If I want to go the other direction, just hit the arrow. I'll leave the draft angle at 0 degrees. And now I have those letters carved into the solid geometry without distorting it. That intermediate wrap feature allowed us to get that shape. Never mind the undercut. We have a hard time molding that. But anyways, that's an example of doing a width draft. And then for just maybe one more quick example, I'm running out of time here, but let's look at just doing another expand with draft. I'm going to take this surface quilt, no solid geometry this time. We'll start an offset. Let's put this on the expand with draft option. And then we'll go in and expand within a sketch. I think I'll put that sketch on this surface. And I want kind of an elliptical shape. So I think we'll use the ellipse option. Draw an elliptical shape about like that. And now it's doing the expand within that shape. I want to start with the side walls normal to the surface and then taper them about 30 degrees from there. So for the draft angle, I'm doing the expand with draft, I can put in 30 degrees of taper. Now I want the side walls to be tangent to the surface I'm offsetting and tangent to that top surface as well. We're going to switch it over to the tangent option. And now it has to bend or curve the sidewalls to match that condition. And then in this model, I now want to offset part of this surface. Don't need the draft this time. So we'll use the one just called expand. And what I want to expand is inside of a sketch I've already made. I have the sketch there with the plus and the minus symbol. So let's grab that surface. Let's start an offset. Don't need draft on this one. So we'll use the option called expand. And then I want to expand within a sketch. As long as the sketch doesn't have text in it, you can just pick an existing sketch. There's no text in that one. So I drew those with lines. And we can do the expand inside of the sketch. I want to cut those down into the part. And now I have an expand, which is recessed down. So this is like the rubber overlay for your remote control. I want to put the word volume across here. Knowing that you can't sketch text within the offsets, nor can you pick a sketch that has text in it, I need to make that sketch ahead of time as a standalone sketch and then trace over it with the project command within the offset. So to show the word volume raised up here, this will be the last thing. Let's take that plane and just make a regular standalone sketch on it. Since I'm in a regular sketch, I can use the text function. For the text, I'm just going to type the word volume. Pick a font to use here, like this one. And then just adjust the dimensions so it fits on the part. Let's make the height of the letters about 24. I think a 12 would center them. A little bigger, maybe 74 on that dimension. So it looks like that's on top of the part. And I've made that just as a standalone sketch. To do the actual offset, we're going to grab this surface, start the offset, put it on the expand operation. And now I need to make another new sketch. We'll define that sketch on the same plane. And again, the reason I had to make the sketch ahead of time is because when I get into the expand, the text function is grayed out here. Not sure why they made it that way, but they did. So I'm going to do the projection, pick any piece of the sketch, go to the options for the project, make it rule-based, get all the curves. And now it's going to do the expansion within that projected image. Let's expand it up at a value of 2. We can hide the original sketch, and we're done. So there's a part that looks like that. All right, so we looked at really one feature here called the offset, but we looked at 4 options within the offset: the standard offset, the expand, the with draft, and the surface replacement. Also talked about a seed and boundary technique for picking a bunch of surfaces. All right, so getting towards the end of our schedule time, just wanted to open it up and see if anybody had any questions. On anything we talked about there. Now, realizing we went over those pretty fast, this has been recorded. This will be posted. So if you want to, slow it down and watch things at your own pace, you will be able to view a recording.
My one question I have.
Sure.
Can you hear me?
Yes.
Yeah. So you did that offset in the control fit and the automatic fit. So the thickness remains same all over the areas.
No.
Say for example, no.
Not necessarily. So when you do the automatic fit and the controlled fit, it's going to vary the wall thickness where it had to. The true wall thickness was impossible. That's why we did the automatic fit or the controlled fit. So you do have a variable wall thickness there.
Okay.
Yeah.
Thank
you. Yeah. Yeah. And that one where I got the bottom to eventually sit flat, it wound up making certain areas way thicker than the number I typed in to do that.
I got it. Thanks.
Yeah. The only one that gives you the perfect constant wall thickness is the normal to surface.
So I've got 1 o'clock. Any last questions? Otherwise, we'll let Mike go. Thank you so much. It was really a lot of content.
Yeah. Thank you. Appreciate it. Appreciate your patience and your time.